Okay, this is Math Message 2-8. This is the main math lesson for the day. If you were absent, use it to catch up. If you were struggling, use it to review. In this math lesson, we are going to be using mathematical representations to solve division problems. Okay, so working on division, which a lot of people think we don't do any division at the beginning of the year, but we're already well into doing some division. And we're going to be using mathematical representations. Now, this is going to be really important, boys and girls. I need you to understand that representation means you're going to be representing this problem with pictures, numbers, or words, or a combination of all of those. I really start getting picky about this time of year when I give you problems to do and you're working out the problems. I really start getting very picky about wanting to know exactly what you did to solve the problem and really being able to understand and see your thinking. I want to be able to see inside your brain. So many times I'll go around and see somebody's paper and they might have the answer on their paper. It might be right, it might be wrong, but then there's nothing to prove how they got that answer. And I always say to them, well, what did you do? Well, I did it in my head, or I know it in my head. That's not going to be good enough this year, boys and girls. That's not going to cut it. When I ask you to show your work or to show your thinking, I need to be able to kind of see right inside your brain and see what you did. So we're going to get really good this year at doing representations and using pictures, numbers, and words. I should be able to look at your paper and know exactly how your brain was figuring it out. All right, so let's look at a couple of problems. All right, you're going to need scrap paper, paper pencil, whiteboard marker, something to be working out some problems. All right, now guys, remember, I want you to be using pictures, numbers, and words. Even if you know the answer right away, I still want you to represent that with some pictures, numbers, and words. Like, how did your brain know it right away? All right, here's the problem. It says there are, let's see if I can make this bigger. There are 20 children in art class. Okay? If 4 children can sit at each table, how many tables do they need? So I want you to pause this video and I want you to draw this art class. There are 20 children in art class. If 4 children can sit at each table, how many tables do they need? Go ahead, pause the video, work that out. All right, so if I were figuring out this problem, I know there's 20 children. That's what I know. I also know that 4 children can sit at each table. So if I start drawing that, I'm going to draw a table. There's 4 kids. Now, I don't know how many tables to draw. It doesn't tell me how many tables. That's what I'm trying to find out. How many tables do I need? So I'm just going to have to keep drawing tables, putting 4 kids at a table, and then seeing when I can seat all 20 of my kids. Okay, so if I have 4 and 4, now I'm at 8. I draw another 4, and now I'm at 12. See how I'm kind of keeping track with a number down at the corner? I draw another 4, and now I'm at 16. And I draw another 4, and I'm at 20. Okay, so now all 20 of my kids are seated. Now, what's the answer to my question? How many tables did I need? I needed 5 tables. I want to see if you think you can write a number model that represents this problem. Pause the video and see what you come up with. All right, here's the number model that goes with this problem. You are taking 20 kids. And what were you doing with those 20 kids? You were dividing them up, weren't you? You were dividing them up and putting 4 at each table. So you were making groups of 4 with them. When you took those 20 kids and divided them into groups of 4, how many groups did it take? 5. 20 divided by 4 equals 5. Okay, so this is the number model that goes with this problem. You knew how many kids there were. You were dividing those kids up. All right, let's try another problem. Okay, so now this one, it says there are 20 children in music class. Okay, so same 20 kids, but if 6 children can sit at a table this time, how many tables do you need? Pause the video, work it out. All right, so this time, every table has 6 kids. So I got one table, there's 6 kids. Got another table with 6 kids. How many do I have now? That's 12. I got another table with 6 kids. Where am I at now? I'm at 18. Getting close. I got to do another table with 6 kids. And what do I have now? Now I have 24. Do I need 24 seats? I don't need 24 seats. I only need 20. But the question says, how many tables do they need? Well, boys and girls, in order for everyone to sit down, I'm going to have to make 4 tables, right? If I only do 3 tables, there's not enough people to sit down, or not enough spaces to sit down. So I have to do 4 tables. All right, now pause the video. This one here is going to be a little tricky. I'm going to be surprised if you can come up with this one, considering we're just getting started with division. But see if you can write a number model for this problem. All right, so your number model, you've got 20 kids. When you divide those 20 kids up into groups of 6, how many groups of 6 did it take? Technically, and I don't expect you to have gotten this answer, it should have taken 3 tables, okay, with a remainder of 2 more. Because technically it took 3 tables and then it took an extra 2 at that other table. So technically 20 divided by 6, you got 3 full groups, and then you've got a remainder of 2 at the other group. Now the reason our answer is 4 is because it says how many tables do you need? Well, sometimes, boys and girls, and we're going to learn about remainders and division here coming up soon. Sometimes when you have remainders, sometimes you just kind of get rid of those remainders. You kind of like, they're just left over. Other times, you need to account for those remainders, and in this situation, you needed to account for them. Those were kids that if you didn't give them another table, they wouldn't have a place to sit. But technically, this is the number model. All right, that one was a tricky one, wasn't it? All right, I'm going to do another problem with you. Now, if you were in class, we actually have this on a worksheet that you would have worked out in class and turned it in. But if you weren't in class, I'm just going to use this video. We'll do it together on the video, and then I'll just have you do the problem in the workbook on your own. All right, so let's look at this problem. It says there are 20 children in art class. If 4 children can sit at each table, how many tables do they need? So a problem just like what we just did. Again, we still have, let's see here, didn't we just do that problem? We did just do that problem. So that just must have been a different, maybe I had done it up in a different sheet. Okay, so we don't need to do this problem. We already did that where we had 4 children sitting at each table. So we're gonna skip that one. All right, so here's what I need you to do. I needed you to turn to page 50 in your workbook. And I want you to go ahead, this is kind of an easy problem, guys. I want you to go ahead and solve this problem. But not only do I want you to solve it, here's what I want to challenge you to do. I want to challenge you to really represent this problem with pictures, numbers, and words so that if another teacher walked in the room and they didn't even see the problem, they didn't even read the problem, I want them to be able to look at your work and know exactly what's going on. So I want you to have really good pictures and really good representations. Okay? All right. So here's the problem. It says that Leah and Matthew share 14 pennies equally. How many pennies does each child get? Again, boys and girls, this is a super, super simple problem. I'll bet you probably already know the answer. But here's what I want to challenge you. I want to be able to really look at that, your representations, and know what's going on. Okay, so go ahead, stop the video and work out this problem with pictures, numbers, and words. Okay, so here's an example of what I'm looking for. Okay, I really represented this problem with pictures, numbers, and words. First of all, I started up here at the top and I wrote down 14 pennies. And then I kind of branched that off and I made a Leah and a Matthew side. And then I divided up those 14 pennies. And so you can see I've got 7 pennies under Leah and I have 7 pennies under Matthew. And I labeled each of those pennies with a P. Now, down here, I actually gave a little, key and said that P equals pennies. And then I wrote my number model. 14 divided by 2 equals 7 pennies each. Okay, so now if someone walked in the room, let's say a teacher walked in the room, I'm going to cover up the problem. And that teacher didn't see the problem, but she just saw your work. That teacher is going to literally know everything about that problem by looking at your picture. She's going to look and see, I see you had 14 pennies. Well, it looks like you took those 14 pennies and divided them up between 2 people, Leah and Matthew. It looks like Leah has 7 pennies and Matthew has 7 pennies. And then the number model shows 14 divided by 2 equals 7. So everything in the problem is represented. Sometimes I'm going to be really picky and expect something spectacular like this, and other times, you know, just a quick little sketch. I'm going to let you know, but I want you to be able to fully represent a problem when asked to do so. That's going to be important in life. I tell the story all the time about my husband being an estimator, and so he estimates jobs, and sometimes he might estimate a job and it might be a job that's going to cost the customer $500,000 or sometimes close to $1 million. Well, if my husband isn't able to represent that estimate and show how he got that, do you think someone's really going to want to pay $1 million if they don't know why they're paying $1 million? So sometimes in life, boys and girls, it's going to be really important for you to be able to explain and to show your work. And so sometimes I'm going to be really, really picky and expect you to do something really great like this representation. All right, guys, that is it for lesson 2-8. This was a quick one.